Now, let's see what question 4 says. So, question 4 is from the chapter Inequalities. It says figure 1 shows a line with equation 2y is equals to x and curve with equation so and so. The region R shown unshaded in figure 1 is bounded by the line so and so. Given that line 2 is parallel to the y-axis. Alright, so this is the line that the question is talking about. This you can see is parallel to the y-axis also. Okay, where were we? Yeah, and passes through the intercept of C. So that means this line, this curve and line have the same x-intercept. Okay, with the positive x-axis, identify the inequalities that define R. Okay, interesting. Now, a good idea would be to first sort of plan and see how many inequalities will you need. So you can see that region R is basically bounded by 3 lines. I mean, I wouldn't say 3 lines, 2 lines and a curve. So basically you need 3 equations, okay? So you have you need the equation of the curve, which you already have. You need the equation of the line, which you already have. So the only thing that's missing is basically the equation of line 2, which is what we're now going to find. Now, what do we know about line 2? We know that line 2 has the same x-intercept as the curve. So here is the curve, which has equation y is equals to 2x minus 1 upon 8 x squared. Now, what I'm going to do now is I'm basically going to find out the x-intercepts of this curve. Okay, and how do you find out x-intercept of any curve in any line? You basically equate y to 0. So that means 2x minus 1 upon 8 x squared is equal to 0. Now, let's take 2 along with x common, or maybe let's just take x common. So if I take x common, so we have 2 minus 1 upon 8x, which is equal to 0. Now solve it like you would solve any other quadratic equation. So x is equals to 0 and 2 minus 1 upon 8x is also equal to 0. So that's why we put an OR. Now x equals to 0 we can see, we can see that the curve is passing through the origin. But the other x-intercept, the positive x-intercept that we're after is what we're after basically. So let's solve this equation. This would be 2 is equals to 1 upon 8x. Upon cross multiplying, we get x to be equal to 16. And there you go. We now have the x-intercept of this curve, which is equal to 16. Which means we now have the equation of line 2. Line 2 is a vertical line. So what kind of an equation does a vertical line have? X equals to the point at which the line is cutting the x-axis. That means the equation of this line is x equals to 16. Now we have all the ingredients and we're now gradually going to start putting them together and form the inequality. So let's do that on a fresh page. Let's one by one start writing down the inequalities. So starting from this line, the region R, which we want, is on the left side. The left side means lesser than and not, in fact, yeah, just lesser than. Why? Because it's a dotted line. Okay, so inequality number 1 would be x is lesser than 16. Okay, and just for your understanding, reason why we're using lesser than sign, because it's dotted. So whenever it's dotted, we use lesser than or greater than. Okay, something that we do in IGCSE also. The other line that we have is 2y is equals to x. So this is the line 2y equals to x. The region that we want is below the line, and notice that since this is a solid line, so that means it's not just going to be lesser, it's actually going to be lesser than or equal to. So that means 2y is lesser than or equal to x. Okay, so 2 down, just 1 more to go. Now the third and the final inequality will basically depend on the equation of the curve. Now the region that we want, region R, is above the curve, so that means y is going to be greater than, and not just greater than, in fact it's going to be greater than or equal to. Why? Because it's the curve is solid, it's not dotted. So y is greater than or equal to 2x minus 1 upon 8 x squared. These are your 3 inequalities, and that's it. Job done. There you go. Easy marks. Let's put a box around it. Okay, and remember, this was just for your understanding. You don't necessarily have to write this in the exam.